Hi, this is Mira Kuntuala, and this is my Exam 1 wrapper. The question I chose to do from the exam was the first question, which is the coding question using the picture provided of a pelican moving downwards in the water. So for the first missing value on the test, it was the initial velocity of the pelican right here. So in order to find this, you're going to want to look at the picture and find the x component and the y component of the velocity, as those are the only two changes in coordinate. So for the x component, we know that the pelican is entering the water with a speed of 15 meters per second. So the 15 meters per second would go here. However, the pelican is also changing direction, and the angle with which he's changing direction is 20 degrees. So drawing a triangle of the motion, you can find the x component using sine of 20 degrees. So the full x component is 15 times sine of 20 degrees. Then the y component is negative 15 because the pelican is moving in the negative y direction. And again, 15 meters per second times now cosine of the 20 degrees, and then the z component is 0. Next is the while loop. So all of the lines underneath while t is less than 1 were empty, and we were supposed to fill them in. So typically for a while loop, we have to make sure to define fnet, because that's what's going to help us to define what the velocity and position update formulas are for the motion of our object, in this case the pelican. So looking at all the forces that could act upon the pelican, we have gravity, which is caused by the earth, drag force, which is caused by air, and those are the two main forces. So right here we define F earth as the vector, and then in parentheses 0 negative g times pelican dot m, which is pelican mass, and then 0. And above these lines, this while loop, we have defined what g stands for, so we don't need to do that. F air now, F air is equal to negative b times the pelican's velocity times its magnitude squared times the velocity. So for this one, again, the b constant here, the proportionality constant, is defined earlier, so we don't need to do that. Now we know that F net is the sum of all of the interactions affecting our system. And in the case of the pelican, the two interactions are the air and the earth. Next, we are using Newton's second law right here to show the position update, the velocity update, and then below the position update. So for the velocity update, pelican.m equals pelican.vel equals pelican.vel plus the net force, which we defined up here, divided by pelican.m times delta t. And then below that, pelican.pause equals pelican.pause plus the pelican.vel that we defined in the equation above times the delta t. And that's how you solve this problem. Thank you.